Black holes are notoriously hard to see, yet they're responsible for the brightest objects in the universe. And those objects are quasars. It's a type of AGN, which just stands for active galactic nucleus, which are basically just supermassive black holes that sit at the center of galaxies, actively feeding on surrounding material like dust and gas. They will even rip a star to shreds if it gets close enough. We can tell whether or not a black hole is active by looking at how bright it is. When matter is falling in towards a black hole, it heats up to millions of degrees. And when it does that, it emits an enormous amount of energy in the form of electromagnetic radiation, which is just a fancy way to say light across the electromagnetic spectrum. And sometimes when a supermassive black hole has a really strong magnetic field, the surrounding matter that's heat up gets shot through the magnetic poles. So not only do these AGN have an accretion disk, which is just a disk of super hot material rotating around the black hole, they also have jets of charged particles that are moving at the speed of light, shooting through these magnetic poles, which gives this object its infamous quasar shape that shines across the electromagnetic spectrum. So we can see these signatures in gamma rays, X-rays, and even radio waves, which is actually how quasars got their name. Sometime in the 1950s, astronomers observed a radio emission from an unknown source that was faint and had light emission like a point source or a star. We ended up calling those quasars, which is just a contraction for quasi-stellar radio source, which basically just means they were star-like radio emissions. The most powerful quasars have luminosities thousands of times greater than that of a galaxy like the Milky Way, but they're so far away that its emission looks like a point source. If we change our line of sight and move the quasar so that we're looking directly into the jet, the emission looks even more extreme and is brighter. This is what we call a blazar. Blazars are just a special type of quasar that has their jet pointed straight at us. So like quasars, blazars also have an accretion disk. They also have a jet of these relativistic particles, but because the jet is pointed towards us, it looks even brighter. But it also makes the emission more variable, which means they're flickering in brightness over hours to days. Even though black holes themselves are incredibly difficult to observe, they create these intense and energetic events that makes it easier to observe processes happening around them. So although we can't image a black hole directly, we can image its surroundings and its effects on its surroundings.